Namaskar. In the today's second session in the series of webinar on organic and biodynamic home gardening, the second session is about home composting and growing medium. So till now we have learnt about the growing conditions and gardening tool in the first session. In the second session of the first day, we have learnt about the indoor and outdoor plants and the details in different segments like vegetables, then fruits, then ornamental foliage and ornamental flowers, etc. Also in that the microgreens, herbs and all. In the second day, first session, we learnt about the season, crop season and purpose for cultivation. In which season, which crop should be cultivated or can be cultivated, again depending on the region. So have explained about the region specific, tropical, temperate region, subtropical region, etc., etc. Now once this much is understood in planning for the home garden, or already if you are doing, then fine tuning our the gardening activities. So comes in the series is home composting and growing medium. So whatever household materials are there from the kitchen and other household organic materials which can be converted into compost and utilized in home garden. That's how can reduce the pollution, reduce the garbage load for the municipal corporation if we are in the cities, or if we are in the rural areas, in villages. Also, instead of throwing it here and there as a garbage, it can be converted into organic, useful organic home compost and can be used in garden. And then once we learn about the composting, and then what kind of growing medium is ideal for different kind of plants, and to know the basics about that. So first I'll talk about a little bit about the nature's way of looking at the thing and doing the things. The power of life. It originates in organic healthy soil. Here you can see the picture, and this is actually a road, middle of the road, you can say, or somewhere near the boulevard in some corner, but you can see that tar is there. The hard crust tar is there. And from that breaking out the few seedlings of the certain plants, certain wheat plants can say. But this is the power of life. This is the power of nature, that this hard crust which can withstand the weight pressure of heavy vehicles, that is broken and ruptured and broken, and just like a volcano, these plants are coming out. So this is the power of life, the power of nature. So what is the relevance of this? The relevance is here because under this road, under this tar crust, the soil is organic, no doubt about that. It is not a soil from any field. It is the soil which was uncultivated and before some time back, maybe a year, maybe an year, or maybe a decade, or maybe a century, God knows. But the soil is organic, and this is the example of that organicness of the soil. And here you see two pictures. One is this is organic soil, and this is chemically treated soil from a conventional farm, can say. And you can see the color of the soil, the texture, of the soil. This view only tells that which one is good and which one is bad. Anyone can say which one is good and which one is bad. This soil is below this, and this is the result. If This kind of soil, had it been below this would not have been visible. This is the simple purpose of showing this picture. So organic soil, what is the power of organic soil? The life force of 600 million to 1 billion beneficial microbes of 15,000 species, more than 15,000 species present in the soil per cubic centimeter. So this is the organic soil. This is the organic soil. This is the characteristics of organic soil, one way I can say, and this is the result of organic soil. And the conventional soil, lifeless soil with as few as hardly 100 beneficial microbes present in the soil per cubic centimeter. So compare this with this, and here in this picture, it is a well expressive picture. And as I said, if this soil had been here, this would not have been seen. So coming to the soil, the different kind of nutrients, let us understand first about the nutrients, plant nutrients, and then we go further. So these are the different 16 type of nutrients which are required by the plants, and it has been divided into 4 groups: the green, red, gray, and yellow. What is the meaning of green? The non-mineral nutrients, that is carbon, hydrogen, and oxygen. Carbon and oxygen plant gets from the carbon dioxide. In breathing, plants breathe the carbon dioxide and exhale oxygen. So carbon dioxide is formed of carbon and oxygen. So plant gets these two from the carbon dioxide, and also hydrogen and oxygen makes the water. So hydrogen is supplied to plant in the form of water. So these 3 elements are received by the plants in the form of carbon dioxide and water in the nature. Next comes the primary macronutrients, that is nitrogen, phosphorus, and potassium. It is called macronutrient because these 3 nutrients are the building materials for the plant, so to say, the structure of the plant. When you make a building, tall building, you need a lot of stuffs to erect that structure. In that, the brick and the iron structure, the columns, etc., different kind of those structures are required in large volume. And along with that, cement is there, the sand is there, etc., are lesser quantity. And then once the structure is erected, then you need the fine tuning, the finer giving the shape, the plastering, then painting, then the window, etc., and then electrification, etc., etc. So if we compare simultaneously with a building structure, then these are the primary structure. Means you require a place for erecting the building, so like that, and then also you require water. So it comes from hydrogen and oxygen, and place the space you can consider as carbon. Then bricks are the macro part in volume, brick and iron. So here in nitrogen, phosphorus, and potash, the plant main structure is created by these 3 elements. So plant require in large quantity. Can say per unit area, if we talk about in per acre kind of thing, generally that is the way it is recommended, or that is the way it is calculated, per acre or per hectare. That way for commercial cultivation, it is in terms of kgs and quintals, if we talk about. But in our home garden, it will be per container pot, so it will be in grams actually. But is a large quantity. As compared to that, the second set is secondary macronutrient, which is calcium, magnesium, and sulfur. These 3 elements are required. If it is in kgs, then it is in grams, or if it is in quintals, then this is in kgs, depending on the unit area. So that's why it is also classified as macro, but secondary, because it requires in lesser quantity as compared to this. And then list of micronutrients are there. like nickel, iron, then manganese, zinc, copper, boron, molybdenum, and chlorine. Out of that, these six, iron, manganese, zinc, copper, boron, and molybdenum, these are important. Nickel and chlorine are again, sodium also is one. That way, there are many other elements are required. But these six in the center, excluding nickel and chlorine, are also very important, and they determine the plant's health. How it determines will come in this session and following slides. So these are the nutrient elements that way, which are supposed to be present in optimum amount, optimum quantity for a plant to grow healthy. And the sequence of uptake of nutrients, here when I say uptake, it is the utilization actually. Sequence of nutrient utilization. Without uptake, utilization is possible, not possible. That's why uptake I have mentioned here. But all are taken in different forms, but together. It's not that a plant requires nitrogen, so it will take nitrogen only. Or plant requires iron, so it will take only iron. It's not that way, but it's all collectively it is required, and different stages of the plant, different quantities are required. How it happens, also I'll discuss about that further. So boron, silicon, then calcium. Silicon is not mentioned here because silicon is readily available in the soil naturally in abundance. Silicon. So it's not mentioned in among this. There is no shortage of silicon as such. Then calcium, nitrogen, magnesium, phosphorus, carbon, and potassium. So this is how the series of nutrient requirement. It's not that you provide nitrogen only and plant will be able to. If boron is in deficiency, all other nutrient uptake will be affected. And suppose boron is present there, but silicon is not present there, which is not most unlikely actually. Come to the next, say for example, calcium. Boron and silicon is available, but calcium is in shortage. Then also these nutrient uptake and utilization will be affected, and it will affect the plant health. Problems will be there. Similarly, these three are available, but not nitrogen, these will be affected. So this is how the series goes on. So organic nutrient, we know about different kind of organic nutrients, and we do use different kind of organic nutrients. But here, a lot of things are very important to understand before we go for any specific type of organic nutrient, because everything is not useful in every way, every time, and every form. So here in these four pictures, if you see, first is the synthetic fertilizer. So there is a red cross, big red cross. This we in organic biodynamic condition of gardening, we should avoid this. There is no place for this of any synthetic material, that for that matter, as a nutrient, and so on. So no synthetic chemical or fertilizer. Then comes the vermicompost. This is the vermicompost. You can see the earthworms here. So vermicompost is also very useful, but then there are certain points in that also I'll explain. And then organic compost and dung manure. This is the dung manure which is readily available in the villages. The cattle dung is collected in a place somewhere central location. It is dumped by all the villagers, and it keeps on piling up, piling up, and after a certain few months, they take it out and use it in the soil. There are many disadvantages of that, which also must know. But ideal is the compost. The most, the best rather, the best soil nutrient for the plants is the compost, the organic compost. Organic compost means the cooked food, cooked, tasty, nutritious food for the plant, which is served in the platter in the form of soil. Soil is the platter for the plants. As we have our food on the platter, similarly, the soil is the platter for the plants' food. We serve the food to the plant in soil. So the organic compost is the best form of food for the plants in cooked form, tasty cooked form, readily available. The nutrients are readily available for uptake. How also will explain. So then coming to the again basics, the organic manures are there in market. You find a lot of different type of organic manure, not the compost. There is a difference between compost and manure. So organic manure is there, and then vermicompost is there. Also, it is a form of compost, but again, this is also equivalent to this, readily available, good thing for the plants in general. But in home gardening, I would suggest to use organic compost rather than vermicompost, because in vermicompost the worm eggs are present, and they hatch. And if you don't like the worms in your house, in your garden, in your pots, in your containers, in your soil, in your growing medium, then rather you can avoid vermicompost, use of vermicompost. Then goat dung manure powder is also mentioned here. See, goat dung is in bowel form. You see that it is in bowel form and very dry. So when you use that directly in the soil, not in home gardening, but generally farmers use it. But because it's dry and compact and hardness, it doesn't get decomposed in the soil immediately. So the nutrient is not readily available. Otherwise, goat compost is very, very useful form of organic manure, so to say, for the plants, because goats feed on different type of herbs, and goat is one animal which can digest all kind of herbs. You will never see a goat having loose motion. Cows have loose motion, buffaloes have loose motion, but all other animals, but never you see a goat having loose motion. Whatever you feed it, but the excreta, the bowel will be in same form. So you can say that that is quite ideal. It is full of different kind of nutrients that way. Although cow dung is the best for that matter. Reasons I'll explain on the last day. It is related with rural calendar also, so I'll explain that day. But goat dung, if you want to use, then you crush it into powder form and then use it, so that the decomposition process will happen. When I say manure, and there's a difference between manure and compost. Compost is the cooked form or digested form, but the organic manure is not the digested form or the decomposed form. Okay, I'll explain it here in further, that you can see here different kind of organic oil cakes are there, like jetropa oil, then pangamia oil or cotton seed oil, moringa seed oil, then sal seed oil, groundnut seed, neem seed, and then mustard seed. Karanja is also pangamia that way. So these oil cakes, when you use directly in the soil, these requires to be decomposed, or the cooking has to be happen, because these are in one can say in raw form, and unless until microbial activity happens in the soil, and then the decomposition happens of this, the nutrient which is in certain organic compound form has to convert into the readily available form for the plants, rather for the microbes to absorb that and give it to the plants. There is a symbiotic relationship between the soil microbes and the plant roots actually. So like this. So if you use directly this, then you might see kind of a certain disadvantages or health affecting the health of the plant, because in the soil some kind of other things happening, some pest generating or kind of things. So best is to have the compost, and that's why if you want to use this, you add it into the home composting. You add it in this organic manure also, because these all are organic manure, so to say, or goat dung powder also. Whatever is available with you, you can use it in small quantities in home composting process. And then the ready compost, which is the cooked food, actually you should use in for the plants in the soil. So what is the difference between compost and manure? So as I said, compost is the cooked form. Organic bio-waste is converted through natural process of decay to change into a valuable humus-like material is called compost. See, here the important word is humus. I'll explain what is humus. And what is manure? The organic bio-waste in its natural raw condition or partially or fully decayed into a non-uniform but changed organic material is called manure. So it is not composted, it is not cooked, it is not properly decomposed. Okay. Now, further, there is a explanation. The compost is prepared from various organic ingredients after going through a process of composting, which can be compared with the cooking of food before consumption. Aerobic microbes, which require oxygen, do the breakdown of various organic compounds in the process of composting. But in the process of manure, where the rotting process happens, it is a mixture of various organic bio-waste which has either not gone through any microbial process at all or undergone rotting process, that is anaerobic microbes, which do not require oxygen, do the breakdown of various organic compounds. So here the importance is about rotting or composting. In composting, it doesn't give any bad smell, because the process is happening through the aerobic microbe in the presence of oxygen. And anything which is happening with the utilization of oxygen generates heat. So in the composting process, temperature rise will be there. But in the rotting process, because the anaerobic microbial activity is happening in the absence of oxygen, so rotting happens, and anything rotting will give bad smell. So anything giving bad smell is not good for health. We don't consume any food which is giving bad smell, which is rotting. It harms our health. It gives disease to us. Same thing happens for the plants. If we give rotten material in the soil as a plant food, actually it is giving disease to the plants. And if we provide composted food in the soil to the plant, it grows well, healthy, strong. So what is composting? Further, let us understand about the humus. Composting is a biological process in which microorganisms convert organic materials like organic kitchen waste and other household organic waste materials like paper, etc., into a soil-like material called humus. So humus is the food for the plants. Humus is the food for the plants, but not taken by the plants directly. In fact, humus is the food for the microorganisms in the soil, which take the nutrient from the humus and provide it to the plant roots. And in return, what they get from the plant roots, they get the sugar from the plant, which is formed in the plant in the process of metabolism, and which is the excreta of the plant generated in each and every cell. We also generate excreta when we eat food. a larger part of the food comes out in the form of stool, which is unutilized by the body, which is not absorbed by the body. But what is absorbed by the body goes into each and every cell, and there metabolism happens, and then some further waste compounds are generated, which are coming out through our urine and sweat. So liquid comes out in the form of urine, the solid comes out in the form of stool, and certain gases are also generated in the cell during the metabolism, which comes out in the form of exhaling the breath. So this is how solid, liquid, and gas is coming out of our body. Similarly, in the plant, also same way, the excreta comes out from the each cell through the system of the plant, released in the soil through the roots, and those are different organic compounds which plant root contribute in the soil, which becomes the food of the microorganisms. So microorganisms take that food from the plant's root, and they provide the nutrient compounds to the plant roots for the plants to utilize. So there is a symbiotic relationship established there by the nature between the microorganisms and the plants. This is prevailing in the organic condition, but in the conventional or chemical soil condition, where you use synthetic fertilizers and pesticides, etc., you disturb the entire ecosystem of the soil, macro level and micro level. Here, more important is about the micro level, as I'm explaining. At micro level, you are destroying that ecosystem, you are killing all the microbes. So just avoid any kind of use of synthetic chemicals. So coming to the compost inoculation, compost inoculation is adding bacteria to start the population growth. Adding a handful of old compost from pile will give base layer a kickstart. So this is for composting process actually. So when you are making compost at home, you need a small quantity of compost for the inoculation of these all beneficial bacteria or microbes, rather that way you require. So therefore, compost is a cooked organic manure which can enrich the soil for longer period and improve crop growth and yield. Because this is in organic form, in humus form, so it remains in the soil. The synthetic chemical form nutrients like whatever urea and DAP, diammonium phosphate, otherwise there are many kind of inorganic chemicals are there, synthetic manufactured chemicals are there. When you provide in the soil, it gets soluble in the soil, and whatever is absorbed by the plant or taken by the plant, rest is wasted. Larger quantity is wasted. Almost only 2 to 3% is absorbed by the plant. More than 95 to 97, 98% is wasted actually. Remains in the soil at different layers. So another important thing is about the CN ratio, the carbon-nitrogen ratio in composting. Very important that way. So here you can see the green and the brown. Green indicating the nitrogen and brown indicating the carbon. So this green is the nitrogen, source of nitrogen. That means anything which is green, for example, the vegetable waste, etc., fruit waste, vegetable waste, etc., which you comes out from your kitchen, are the green and source for nitrogen, and the dry or brown are the source for carbon, like the dry leaves or the twigs, etc., or paper kind of thing. Here is a long list actually of brown and green. You can see dry leaves, straw or hay, then shrubs, pruning. If you are pruning any trees or branches or shrubs, the twigs are there, the branches are there, woody branches are there, wood ash, newspaper, cardboard, kind of thing, sawdust, eggshells, etc. all come in the green. This thing, eggshells are good source of natural calcium actually, like that. And here is the green source, vegetable scraps, fresh grass clippings. If you have lawn, The weeds also that way. Then the chicken manure, if you can source coffee ground filters, if you're preparing coffee, the remaining of the coffee and tea leaves, etc. Then corn, sweet corn, if you're eating the stock of that, etc. Different kind of leaves, even cow dung, cow urine, all are source of nitrogen that way. So there has to be a balance. And what is the ratio? 25% to 75%. So by volume, when you are adding, you add a green 25% and brown 75%. If there is an imbalance in that, then what happens? Because green contains water also, and this brown is dry. So if you add more green, then the moisture content will be more, and if you add more brown, then the moisture content will be less. And that in the composting process here, if you see, there are 4 elements that way: air, water, earth, and fire. These are the 4 elements. So if dryness is there and heat is more, then it will be there will be a burning. You will see ash formation is happening, white ash kind of thing in patches inside the composting bin or wherever you are making the compost. And also along with that, you might see some kind of pills bug kind of organisms, or the mildew type of things, the powdery, powder form of mildew, not powdery mildew, the white mildew kind of things, etc. And on the other hand, if you, these 2 elements like water and earth, earth means coolness and water means wetness. So if it is too wet and cool also, then you will see some maggot formation, the darker color, blackish color, and the petrification kind of thing happens. So you have to measure, as I have told earlier, the pH meter, the moisture meter together in one instrument. So if you have that, you can measure the moisture percentage, moisture level in the compost bin at different levels. And if you find that moisture is high, too wetness is there, then you have to add more of carbon. And if you see more dryness is there, then you have to add more green. Ideally, this is the condition where there is a perfect balance. And then in that, how you will understand by the color, a brownish color rather than the lightest grayish color, or dark brown or blackish color. If it is perfect brownish color, and if you have added some vermicompost in that, then you might see some earthworms also, but unlikely, because during the ideal condition of composting process, as I said, temperature, heat generates and the temperature goes high, and sometimes it goes beyond 60, 65, up to 70 degrees centigrade. But in household compost bin, it is very difficult to reach that temperature. It will be still, it may be 45 to 50 degree plus, or maybe up to 55 degree at the core, at a certain level where the perfect condition is there. So earthworm survival is difficult. So treatment, temperature building up at the center core and pattern of humidity distribution from central core towards the edges in all sides. That should be watchful about that. These are 2 most important factors in process of in processing and the quality of compost, as I have explained here. So temperature and humidity are precisely responsible for cooking of the raw material, turning into good quality compost. Here, if you, I have mentioned the word cooking. So in the process of cooking, if too much water is there, then also cooking becomes bad. And if too much dry is there, then burning happens. So same thing is happening in this composting process also. So you can apply your experience of cooking in this cooking also, that is composting. So for home composting, different kind of possible, designs are possible, different kind of methods are possible. If you have open ground, for example, then this kind of inverted vessels, where the tapering part should go into the ground and the wider open part should be on the upper side. You open the other side also, and then bury it in the ground. Before that, you make all size different kind of holes, finger thick hole you can make on all the sides, so that the penetration of worms and other organisms from the soil also can uh, be both ways, inside out and outside in also, which will work on the material inside for the composting, and keep on putting in different piles, the green fruit, vegetable, and scraps, etc., and then some sort of quantity of worms or the compost for inoculation of worms and the microbes, and then the brown, etc., different layers, and keep on checking about the moisture level and the temperature level. For temperature, of course, specific kind of thermometers are available. Otherwise, if you check the moisture level also is more than sufficient. And as the compost gets ready, it will go down and down, and from there it will start releasing in the soil, and slowly it will spread in the soil. You need not to do anything, just keep it covered and with the aeration. So you can have one or two holes here and there, so that aeration is happening properly, and you keep it covered all the time. Just open the lid and put your materials in the bin, and composting process will be continuously happening. And if you have large quantity of waste, then you can have this kind of multiple locations in the ground, open ground, if you have large area, open area in a bungalow or kind of thing. But if you have terrace, then a different kind of structure you can work with. And this is the 3-layer structure. Many kind of similar structures are available in the market, also different designs for this very purpose only. 3 layers, and bottom is the layer is there where the things are, any kind of liquid which is coming out will be collected, and the bottom layer is the ready compost. Here the composting process happening, and here you are adding the thing, and it keeps on moving downwards as you keep on removing here. In the next slide, it is explained in a better way. Basically, this is the kind of structure you can have. Again, this kind of plastic structure also is available, or can have earthen structure like this one mostly, and you can remove this and then extract the compost, or you can have a plastic structure where the gate is there and these 3 layers are there. From inside, this is the structure for aeration. Inverted funnel is there, and then for aeration, windows are there, you can see here, and your lid is there. You remove the lid and put your composting materials, and keep on checking at the bottom from the bottom gate, and from the top about the composting process. Check the moisture level, etc., and accordingly you keep on mixing the green and brown. Only thing is that you must have the balance of green and brown. That will be possible to check, judge by the level of moisture at different stages, different levels, different layers, and different places within this compost bin. Adulteration of compost is very important. So here, if you are buying from the market, then be careful what you're buying and whether you are being cheated or not. Here you see this is adulterated with charcoal, and when you hold it in your palm, you see the charcoal black color will make your palm also colorful black color that way. So if it is a pure compost, you take in your hand and squeeze, nothing will stick to the palm. Your palm will be as clean as before. That is the proper good quality compost. But any kind of adulteration, if it is charcoal, it will make your palm black. If adulterated with cocoa peat, then it will look more brownish and more fluffy and more air. A lot of aeration will be there. But then cocoa peat, the fibers in particle form will be visible. The compost is cooked. So in compost, as I said earlier, the humus form. So none of the organic material which is used for the compost will be in the original form. After composting, all the form will change, into one uniform form, which is humus. Then this is adulterated with the soil. So to make it bulky, so to make it voluminous, coco peat is added to make it fluffy also, to make it light and volume wise. The coco peat is used to make it more brown actually, to make it darker color, and heavy also. Charcoal is used, or sometimes soil is also used. And when soil is used, again, when you take soil in your hand and rub in palm, between your palm, the soil particles, the clay particles will stick to your hand. As I said, pure compost, nothing will stick to your hand. Or sometimes the pressed mud also is mixed with this compost in the market. So if a pressed mud is available, added in the compost, then you will see that dryness is there, and particles, if you observe it taking in your palm, you will find that instead of uniformity, some kind of unevenness is there in the entire formation. Maybe in the soil adulteration you will not find it, because soil also contains a lot of humus if it is organic soil. To increase the weight, soil can be added. If it is not blended properly, then it will be visible in lumps, actually, moist lumps also, and this will be dry lumps kind of thing. So black charcoal powder sticks to palm when rubbed between the hands, as I said. Similarly, color turns to more brownish and texture turns to more fluffy when adulterated with coco peat. Adulteration with soil increase bulk density, weight of the compost. So soil is added without changing the so-called texture to some extent in pure compost, to increase the weight of the compost. So less compost, but more weight, because compost is sold in the market by weight. So that is one kind of cheating. Adulteration with pressed mud increases the bulk density and weight also, but then dryness will be there, and the uneven, ununiformed texture will be there. And there are many other organic materials used as filler to increase the weight or volume, or both. So pure compost, the best way to check is you take in your palm and squeeze in your hand. In your palm, you squeeze it and then release your palm, and just nothing will stick to the hand. And if excess moisture is there, if when you squeeze, a droplet of water or will fall. But in perfect compost, even after squeezing also, not a single drop of water will fall, drip actually, although it will be moist, not wet. If wetness is there, then after squeezing, water will drip. Understanding about the composition of the soil. So whichever soil we talk about, whichever growing medium we talk about, two parts are there. 50% part is about has to be about water and air, and balance 50% part in that the mineral components, that is sand, silt, and clay, and up to 5%. This is 45%, and this is maximum up to 5%. I'm talking about the natural condition. Any place which is undisturbed, naturally preserved. In that, if you see analyze the soil, physical analysis, if you do, you will find that the solid part is 50%, liquid part is 25%, and gas part is 25%. And among the solid part, the 45% or more will be about the sand, silt, and clay, and other materials. And up to 5% will be about the organic material, or can say humus. And in that humus only, in this 5% only, all other microorganisms, etc., remain. So what is this mineral component, sand, silt, and clay? So what is suitable growing medium for growing plants? So let us understand a little bit detail about this. Soil is made up of sand, silt, and clay basically. As I've explained here, this is water and this is air, and these are the organic matter which contains the living organisms as well as the debris, dead organisms, and like that. So this is not the solid part. This is the component of the soil, that way you can say. So sand, silt, and clay. Soil quality is not determined by its color. First thing we must understand that generally in any nursery or wherever you go or whichever source of information you refer, generally it is recommended that red soil is better. No, it's not that way. The color is not important. The texture and structure of the soil is important. And when I say soil, here I'm talking about the growing medium in totality. But without soil, growing medium is incomplete that way. So let us understand about the texture and structure of the soil. The texture is the ratio of sand, silt, and clay in soil. Okay. And then next is the pH and EC, which I've already explained earlier, is important because the pH and EC is the two factors of the same coin, two sides of the same coin. pH determines uh, the availability of the nutrient. Nutrient may be present in the soil in abundance, but whether it is available for the plant or not will be determined by the pH range. Every plant has got its own ideal suitable pH range. And earlier I've explained that 6 to 7.5 is the most suitable range for most of the plants. So at different range of pH or different pH range, the different nutrients are in available form, maximum available form, or as the pH goes down or downwards or upwards, the availability of nutrient gets reduced or increased like that. So we must know the pH range of the plant and also the pH level of the growing medium. And similarly, the electrical conductivity. The electrical conductivity makes the nutrient mobile in the soil. It is available because of the pH, suitable pH. But if EC is not suitable, EC actually is the electrical conductivity. You can take example of the battery. If you know the structure of the battery, there are two sides. One is positive electrode and the negative electrode. And inside the battery, from the positive to the negative, the electron moves. So that is because of the conductivity inside the between the medium between the two electrodes. Similarly, in the soil, the all the nutrients move in the soil in the radical form. In the radical form, that is either positively charged or negatively charged. And accordingly, the more the charge, it will move in larger quantity and faster also. So that's why these two are important, and these two are they do complement each other. So we must know that. And for home garden, as I have suggested, knowing the water EC is also sufficient actually. Then comes the next, what we should mix in the soil, basic soil, to make it more useful for the growth of the plant. So we to make it more fluffy, more airy, and more accommodative for the water, etc. Cocoa peat or sawdust or kind of materials are used. So mixing the cellulose, that is cocoa peat or sawdust is actually cellulose, enhances the soil aeration and water holding capacity. The 25% plus 25%. So this makes the 50% for the aeration and this thing. And ratio of cocoa peat and or sawdust determines the root growth and nutrient absorption also. Because if there is no space between the soil particles, then root will not get the space to grow. So this makes the space and also the space for the humus, to accommodate the humus and also the microbes. And then comes the humus or the manure, compost, the staple food for the plants in growing medium is the humus or organic matter. As I said, up to 5% naturally, but generally, if you ask anyone, the 1 plus or between 1 and 2 is also quite good. Generally, in conventional soil, the farming soil where chemical fertilizers and synthetic chemicals are used, the humus level or the organic matter level is less than 50%, I mean less than 0.5% or 0.25% also. So 1 plus is okay, but if it is even higher, 2 plus 2.5 or 3 is good. And in home garden it is possible because you grow in container, and in container whatever you are applying, it is remaining in within that system only, within that container only. So you can just have it on higher side. So basic mixture of growing medium should be in perfect ratio of the above three constituents. So what should be the perfect ratio? The perfect ratio is this should be 50%, this should be 25%, and this should be 25% to make it initial mixture for pot filling or for filling the container, because this will be slowly kept on utilizing by the plant, and this quantity will get reduced, and you have to add, but you cannot add in that quantity, in original quantity, never, unless until you do the repotting and you prepare the mixture again. So 50% of this, the soil, 25% of cocoa peat or sawdust, and or maybe peat also you can use, but I will not suggest peat, rather this is better, and compost or manure. Here you must keep in your mind about the difference between manure and compost. When I say manure, the cooked form, that is compost. So to understand further about the soil, the silt and sand, silt and clay, here you see there is a mix of three different type of soils are there. This is on the reddish side, this is on the brownish gray side, and this is on the more brownish and reddish side, to differentiate actually. But here it is more of silt, here it is more of sand, and here it is more of sorry, here clay, silt, and sand, and this is the triangle. You have to have a ratio where your formation should be somewhere like this, clay loam, depending on the percentage. Here if you see, the higher the clay, it is sandy clay, or sandy clay loam, or sandy soil, or loam sand, the silt loam, or silty clay loam on the higher side, or silty clay, and here clay loam and loam. So the balance is here. Balance is here means almost all should be in same quantity almost, but 30 to 40%, 30 to 40%, 30 to 40% is the best actually for any soil, and that is the thing which you get here, somewhere here at the center. How to measure that in your soil? When I say soil, I am talking about without, before mixing the cocoa peat, etc., or any other thing, compost also. Just when you are sourcing the soil from wherever you are sourcing, first check it for the physical properties. And to check your soil, this is the method. You take a jar, this kind of jar, and then you fill the soil, remove all the other materials, any twigs or any leaves, part of leaves, or filter it actually with a fine filter, because the filter or any sieve in which sand particles also can be sieved, but anything bigger than sand particle can be separated. And then you fill it 1/3 of the jar, and then fill the jar with water up to the neck, can see here, and then close the lid, and then shake it well, so that the entire soil is mixed in the soil solution, and then keep it in a cool, calm place where there is no disturbance for almost 24 to 48 hours. What will happen? First, the heaviest particle, the sand particle, will settle down. Then in next 10-15 minutes, the sand particle will settle down. And then in another 5 to 6 hours or so, the silt particle will also settle down. You will see that the water is getting clearer and clearer, but clay particles which are almost in colloidal form will take more longer time. Not exactly colloidal form, but because it is very minute powder form, so it will take time because it's very lightweight. So slowly it will settle down, and this water will become clear and clear and clear. And then once it's settled down, you measure the height of this, the entire height of this, and then separately the height of the sand part, the silt part, and the clay part, and calculate the percentage wise how much is the sand part, how much is the silt part, and how much is the clay part. And accordingly, we will come to know where in this chart your soil comes, which category. And accordingly, you can add, if you can source a little bit of sand or little bit of silt or kind of thing. If you don't get separate sand or silt or clay that way, leave it as it is, but add the compost and the cocoa peat more and more, because cocoa peat also will get converted into it will get it will get decomposed in the soil, and slowly your soil automatically will become somewhat like this and this. It will take time, but this is can say something ideal, where everything is almost in the range of 30 to 40 or something like that. So soil pH, EC, and temperature, I told that is important. So nutrient absorption by plant root happens at certain suitable pH and EC range in the soil. So soil pH, it indicates the acidic or alkaline properties of the soil. Already ideal condition is 6 to 6.5. A wider range is up to 7.5 actually. The certain crops prefer acidic or alkaline soil. The pH makes all these things I've already explained. So I'll come to the temperature directly. The temperature around the root zone in the soil determines the electrical conductivity, which in turn regulates nutrient uptake by the plant roots due to change in pH of the soil. So temperature actually regulates these two factors, because the temperature means soil temperature, and soil temperature means the moisture in the soil. The soil solution of the nutrient regulates. If temperature is higher, it will be moving upwards. If temperature is lower, it will be moving downwards because of the air movement inside the soil. So it regulates the EC. If temperature is higher, it will soil will be drier, so pH will be disturbed. Also, EC will be disturbed. So it all perfect balance of this is required. And soil temperature, I have explained not here, but in my book. I'll talk about the book on the last session. So here, taking the example of few crops, vegetable crops, just for example, here you can see the suitable pH range and the suitable EC range, electrical conductivity range. And for all crops, it is not same, not the pH, not the EC. So if you know your electrical conductivity of the soil, is very good. But if you don't know, at least you can know about the water EC level. That also will be sufficient. And accordingly, you can plan your plants. Okay, which have wider range, like for example, tomato will grow easily. Which have very narrow range, you can say, for example, here 2.5 to 3 for cabbage on the higher side, or on the lower side 1.7 to this thing, or even lower here 0.8 to 1.2, the very narrow range. Difficult to grow in the soil which is outside this range, can say. The plant will not grow very healthy. It will not look very good. So that's all for today in the growing medium and about understanding the soil, etc. So thank you. Namaskar.